In 1609, Galileo used a telescope to peer deep into the night sky. Now, 400 years later, observatories from around the world are participating in a year-long birthday party, making 2009 the International Year of Astronomy. Many of you have already participated in the historic undertaking. By casting your votes earlier this year, you, the public, chose what the Hubble Space Telescope should be looking at during this astronomical marathon. You selected a trio of galaxies known as ARP 274. So now what? Well, to find out, we are here at the Space Telescope Science Institute in Baltimore, Maryland, where the Hubble data gets processed. So Max, you're the first stop in Hubble data. So tell us, can you show us what's happening with ARP 274?
You know, for an object like this, people might be surprised to know that we actually take, in this case, 16 separate images, which will eventually be combined into one color image at the end. And so it does take a little bit of work to clean up the images. And the telescope also takes images just with one filter at a time. So to make a color image, we have to combine images from different filters. While we're taking the image, each of these images is about over 1,000 seconds long. And as we're sitting there taking this exposure out in space, you know, Earth's atmosphere protects us all from a lot of radiation that's flying around in space. Of course, Hubble is up above the Earth's atmosphere. So as we're taking these 1,000-second exposures, it's being bombarded with radiation. And these are high-energy particles that are flying through space called cosmic rays. And they go right through the telescope. They're not going through the optics and being imaged like this galaxy. So they just pepper every image that we take with Hubble. So a main part of my job is taking multiple images and combining them together. And the way we do this is, of course, if I take 4 images in a row of this galaxy, the galaxy is going to be in the same place, but these cosmic rays will be in random positions in every image. So
then you can discard it.
Yeah, it's easy for, you know, we have software that then says, okay, the stuff that's in the same place in every image stays, it must be real, and the stuff that, you know, is in random locations in every image must be cosmic rays, get rid of it. And you end up with a nice clean image.
Okay, now that we have the cleaned up image, now we're going to put it all together, right? So we have the image dude here, Zolt LeVay. Tell us what you're going to do now.
So the images come down as grayscale black and white images. Even though Max was showing them in color, it was a applied color that had nothing to do with the color of the filter. So
just makes it easier for him to see.
It makes it easier for him to see and display and show various features. So the first step, we make the blue image blue.
Yeah.
We make the visual image, the V image, we make it green. The filter's not really green, but we're using what are called additive primary colors. So red, green, and blue are primary colors that when they're added together, they produce all the colors that you can display or that you can see, from black to white through all the range of colors. So then the third filter, the I band filter, or the red near infrared filter, we apply red to it. And we also apply red to the hydrogen filter because that it's red light that we see. So now we put all those together. Start here with the blue, reapply the color, add the green, and add in the red. And there we basically have our color image. We also want to add in the hydrogen.
So Mario, what do you think of this image?
I really couldn't have hoped for something better. You know, when people were voting, we weren't sure which image will turn out the best, but it appears that, you know, the people knew what to choose, and this is really fantastic.
So there you have it, the latest Hubble image, but it's an image you chose.